right? So we have these three forms. The vertex form gives you your vertex. The intercept form gives you your intercept form. And then the standard form, why is the standard form nice, y'all? Does it give you anything just right off the bat? What does it give you, y'all? What is that C value? Gives you that y-intercept, right? So there are some different positive things about each form that we have. So guys, but one thing I want you guys to pay attention to, when something is inside of the parentheses, it behaves the opposite of what you think, right? So when we take x minus h, a times x minus h squared plus k, your vertex is a positive h and k, right? So it changes the sign there when you take it out, okay? Instead of it being a negative, it's going to be a positive, and vice versa. If it was a positive, it would be a negative. The same is true in your intercept form, y'all, because it's inside that parentheses. It behaves the opposite of what you think it will, right? So if my two intercepts were a positive 2 and a positive 4, then in here it would be x minus 2 and x minus 4. So guys, what we are going to do is now we are going to start with a table or a graph, and we are going to try to write the appropriate equation. Guys, and it's not too bad because we can identify our vertex or our intercepts. But guys, the thing that is a little bit trickier about it is we have to find this A value. We don't know the A value. So what we're going to need to do is we're going to need to plug in our stuff and then pick a point to help find our A value. And that's going to be the case every time, at least with vertex and intercept. With standard, I'm going to refresh you guys how to use that regression on the calculator. So for numbers 1 through 4 here, we're going to talk about this in vertex form. So I'm going to kind of zoom in on number 1 here. This is if you have a table. All right, guys? So if I have a table, the very first thing you want to do is you want to identify your vertex. So y'all, where is my vertex? Okay, 2, 5. Excellent. Okay, now what made us recognize that that's our vertex? Excellent. So one thing Zach said was that here we were going, our y values were going down, 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 and then they started going up, up, up. So that change in direction is our vertex. Did anyone else see something that helped them kind of identify that as the vertex? It's your lowest point. That's great. Guys, I also like it because my table is symmetrical. My y values are symmetrical around my vertex, okay? So my vertex is going to be 2, 5. Are y'all cool with that? So I'm going to pick that point as 2, 5. And then, guys, so what I'm going to do first is I'm going to write my equation in vertex form, and I'm just going to fill in the values that I know. So I'm going to kind of like build a little shell here, and I'm going to fill in the values that I know. So we have, remember, our vertex form is y equal, or f of x equals a times x minus h squared plus k. So I just built a little shell here. Instead of f of x, I put y. We do not know our a value. So then I plug in my a value. What is my x value going to be, y'all? Oh, yeah, and it's going to be x minus 2. Very good. Okay, not x plus 2. And then our k value at the end here would be plus 5. Are y'all good with that shell so far? Okay, so this is kind of our shell that we're working with. We almost have our vertex form, but we don't know what the a value is. So y'all, what we have to do is we have to pick another point, and I recommend picking one that is right next to your vertex on either side. So I'm going to pick the point 3, 11. Okay, so this is my x, y, and this first one was my h, k. Do y'all feel good about that? Okay, so we picked one point right next to it. Now I'm going to take this point and I'm going to plug it into this shell equation we have made. So I'm going to make this, instead of y, I'm going to plug in an 11. So y11 equals, we don't know the a value yet. That's what we're trying to find. And my x value is 3. And we still have minus 2 squared plus 5. All right, so what I've done is I've plugged in my h, I've plugged in my k, I've plugged in my x, and I've plugged in my y. So there's only one variable remaining. What's the variable that remains? Our a. So now we can solve this for a. Yes, sir?
Can you just on like any point, like the 1 to x? Like,
you could have picked any point. I just recommend picking one next to the vertex, because then it makes this a little bit easier. Does that make sense? But technically, Owen, you're exactly right. If I had done 0.29, that would have worked just as well. Okay? So you could do any point, and you should get the same a value every single time. Okay? So then we go here, and now, guys, I'm going to kind of just switch to one color so I don't have to keep going back and forth. So I'm going to go ahead and simplify this. So we have what? 11 equals a. And then we do 3 minus 2, and this is why I pick one really close, because 1 squared is really easy to do, isn't it? So 3 minus 2 is 1 squared plus 5. So guys, 1 squared is just 1. So now I have 11 equals a plus 5. So what is my a value equal to? 6. So 6 is equal to a. So guys, now that we know my a value is equal to 6, we can plug it in this first lovely equation right here. So guys, my equation would be written as y equals 6, because that's my a value, times x minus 2 squared plus 5. So that is how we find our a value. Does that make sense, y'all? Oops, sorry, I'm a little off the page. All right. Now, what do you think is a good way that we can check ourselves to make sure this is actually correct? Okay, we could solve it back out. Guys, what's another recommendation, Cole?
Put in the calculator.
Put in the calculator. And let's look at the table and see if the table matches the one we have here. I love that. So I'm going to go here. I'm going to say y is equal to 6, parentheses x minus 2 squared, plus 5. Do y'all feel good about that? Okay, and then we go here, and I'm going to check my table. I'm going to scroll down 0.29, 111, 25. Oh, gosh, that's hard to see. Sorry. 0.29, 111, 25, 311, 429. So are we good? We are good. So that means that we got the correct a value there. So really, guys, that is all we're doing is we're plugging stuff in. We plug in our h, we plug in our k, we plug in our x, and we plug in our y. All right? So that's what it looks like from a table. Now we're going to try the same thing, but we're going to do it from a graph. So now we aren't given the points. We have to find the points. And so, y'all, number 3 is a great example of why we would use vertex form instead of intercept form, because are there any intercepts on this graph? Well, yeah, I guess you have a y-intercept, but are there any x-intercepts on this graph? No, it never crosses the x-intercept. So in order to write this equation, we would have to use vertex form. So y'all, what is my vertex in this case? 3, 2. Do y'all feel good about that? So there's my h, and there's my k. And then before we get going too far, let's pick another point that we can use. What would we have here? What's another good point? Oh, we got one here. 5, 4. Y'all cool with that? So I'm going to go ahead and pick that point now. 5, 4. So we have my x and my y. All right? So then we're going to go here. I'm going to plug in just my h and my k first. You don't have to do that. I guess you could plug them all in on the same step. So y equals a parentheses x minus my h value is 3. And then squared. And then we're going to go ahead and add a 2. Are y'all good with that? Because that's my h and my k. Now, Now I'm going to go ahead and I'm going to plug in my x and my y. So my y value is 4. So 4 equals, let's see here. Still don't know what my a is. That's the whole point. We got to find our a. So, I don't want to do x. What do I want to plug in? What do I want to plug in, y'all? 5, sorry. Okay, good job. There we go. Yikes, that's why you use an eraser, right? Okay, so 5 minus 3 squared plus 2. Are y'all good with that? Okay, so now in order to solve for a, we go ahead and we start reducing. I'm just going to switch to one color. So 4 is equal to a, and then 5 minus 3 is 2 squared plus 2. Y'all good with that? So, guys, 2 squared is going to be 4. So 4 is equal to 4a plus 2. All right? Then I'm going to subtract 2 here. So 2 is equal to 4a. Divide both sides by 4. And what is my a equal to, y'all? 1/2. Do y'all feel good about that? Also, look at your graph. Does that make sense for my graph? Is a positive? Yeah. Does my graph open up? Yes. So that should make sense here, all right? So then my official equation would be y is equal to 1/2. And then we're going to go parentheses x minus 3 squared plus 2. So we are going to plug it in without the x and the y, with just the a, and that would be the equation. And the way that you can check yourself, y'all, is you can go ahead and type this lovely equation into your calculator. Y equals, I'm going to go ahead and do it in my fancy fraction form, 1/2 x minus 3 squared plus 2. I'm going to hit graph. I'm going to make sure this generally looks the correct graph. Does that look pretty good, y'all? There we go. I can even go to my table and check my points. We have 3, 2, which we wanted. We wanted it to be 3, 2. And we also wanted to make sure we had 5, 4. So both of those points that we picked out are actually in our table. All right, guys? Do y'all feel pretty good about that? So what I want you guys to do is I want you to do the same thing on numbers 2 and 4 on your own. All right, guys? You have one table and you have one graph, and I want you guys to write the lovely equation using that vertex form.
Isn't number 2 different though? Is that the right part of fx?
What? So, good question. Okay, so Owen was asking if number 2 was different. So, yeah, I'm going to unpause. There we go. So number 2 is not going to be different, you guys. It talks about f of x, because really, guys, f of x is the same thing as your y values. All right, y'all? So good question there, Owen. Number 2 is actually not all that different, all right, because your f of x is the same thing as your y values. So I'll leave those examples up, and then I'm going to walk around, and we're going to check and see how we're doing. So guys, this is the correct answer for number 2 here. All right, guys, you have your vertex of negative 3, 10, and I picked the x and y value of negative 2, 6. You could pick any x value to make it work, x and y value, but y'all, I picked negative 2, 6. We plug that guy in there, and then guys, once we plug it in, we are just solving for our a. So in this case, my a value was negative 4. The most common mistake I saw is we weren't picking either the correct vertex or we didn't make that x plus 3, right? It was an x plus 3 because, guys, whenever it's in the parentheses, it behaves opposite of what you think. For number 4, y'all, we did a lot of the same thing here where we have, we picked our 2 points. I did 4, 1. And 5, 3. All right, guys, I did 4, 1, and 5, 3. And so when we got this here, it should work no matter what your equation is. Okay, guys, it should work. So we had this. We did y is equal to a times x minus 4 squared plus 1. All right, y'all. And so then we had our 3 was equal to a times 1 squared plus 1. Subtracted 1 from both sides, and we got our a is equal to 2. Now, I know that some of us also, if we had picked the point 6, 9, then we would have had 6 is equal to a, 9 minus 4, plus 1. So, guys, you should still get your a is equal to 2 when you do that. So, I will go around and we'll check on that and see what is going on, all right? But we should still get that our a should be equal to 2 right there. And actually, the point, that's what it is. It's not 6, 9, Dylan. It's going to be 6, 10 instead of 6, 9. Okay, so some of us, I saw some people pick the point 6, 9. The point is actually 6, 10. So that one was a little bit tricky. So try to pick the points that you can see. So our correct answer was y equals 2 times x minus 4 squared plus 1. Do y'all feel good about that? All right. So, guys, now we're going to do the same thing, but instead of vertex form, we are going to do this with intercept form. I personally think this is easier with intercept form, but you have to know your intercepts. Okay, y'all? So, what I want you to do is take a look at this. Intercept form, y'all. I'm going to write it up here. Y equals a, x minus r1, parentheses x minus r2. So, guys, with intercept form, here's the thing about intercept form. We use intercept if there's not a vertex that is readily available for us. So, guys, if you are looking at the table for numbers 5 and 6, you will see, guys, your table is symmetrical, but it looks like my vertex is going to be somewhere between this 5 and 6. Does that make sense? So that means my vertex is not a whole number. All right? So, and the same is true here. Your vertex is somewhere between that -1 and 0. So, guys, if you cannot see your vertex easily, then you want to make sure that you can use your intercept form. I personally think intercept form is a little bit easier. So if you can see your intercepts, then you want to do that. So, y'all, what is my intercept on number 5 here? What is one of my intercepts, y'all?
4070.
Okay. So here is one of my x-intercepts at 40. And here is the other x-intercept at 70. So, y'all, that means R1 is equal to 4, and R2 is equal to 7. Do y'all feel good about that? Locating your x and your y intercepts. Y'all feel good? Okay. So then, guys, what we're going to do is we're going to plug this in to the shell of our intercept form here, okay? So we're going to say, okay, y is equal to, and then our a, we don't know the a value yet, okay? And what I'm going to do is I'm going to make a little shell here without my values. I'm going to say x minus and x minus. So, guys, my first intercept is what? 4. So it's going to be x minus 4. My second intercept is 7, so it's going to be x minus 7. Do y'all feel good about that? Okay. Now, in order to do the next part, y'all, we just need to pick a point, x, y. And guys, I just recommend picking one point that's next to your vertex. On this table, literally every point is right next to at least one of the vertexes. So it doesn't matter. So what I'm going to do is I'm going to pick ones that have positive values because I think that's a little bit easier to deal with. So I'm going to pick 8, 8. All right, guys, so that is going to be my XY that I pick, my 8, 8 there. So, and it's the same number, so I can't screw it up, right? I'm plugging 8 for my X's and 8 for my Y's. So that's going to be 8 is equal to, let's see here, we don't know the A value. 8 is equal to, not X minus 4, but my X value here is 8 minus 4. And then we're not going to do X minus 7, but we're going to do 8 minus 7. Do y'all feel good about that? Okay, now we are just going to simplify it, right? The only unknown variable here is A. I'm going to say 8 is equal to A times, what's 8 minus 4? 8 minus 7 is just 1. That's why you always pick 1 right next to it, because it makes it 1 or negative 1. It's really nice. So now we have 8 is equal to 4A. I divide by 2. I not divide by 2, divide by 4. And my A is equal to 2. Do y'all feel good about that? So I had 8 is equal to A times 4 times 1. That's 4A. Divide both sides by 4. And my A is equal to 2. Now that we know my A value, we can plug it back in up here. So my equation would be Y equals A is 2, parentheses X minus 4. Close that parentheses up, and we do X minus 7. And this right here is the intercept form of that equation. Do y'all feel good about that? I personally think intercept form is a little bit easier because you don't have to square anything. But it's at least easier to find that A value. All right? So we have Y equals 2 times X minus 4 times X minus 7. Y'all feel good about that? All right. So now, guys, we're going to do the same thing with number 7 here. All right? Now, guys, technically, you could do intercept form or vertex form on number 7. Do y'all see that? You could write it in either way. Because, guys, look, we can identify our intercepts pretty nicely and easily, and we could identify our vertex. So, y'all, this is one where you would get to pick which way you do it. Today, I want you to do it intercept form. But, guys, on the test or something, if it said write the quadratic equation and it didn't specify, you could pick which way you're going to go. All right? All right, so here we go. It says your R1 is equal to 1. What is my root 2, y'all? What is my second root? 5. So we have R1 is equal to 1, and R2 is equal to 5. So now we can write our equation in here that we know this. We don't know the A value yet. So we're going to say Y is equal to...
Can we use the vertex as the XY?
You could, yeah, you could use the vertex as the XY. Y is equal to A, and then parentheses X minus 1. Close that parentheses up, and then we have X minus 5. Okay, close that parentheses up. Now we have to pick an XY point. You could pick any XY point as your vertex. You can pick any point as your XY. I personally like to pick ones that are right next to it, but you could pick 4, 3, you could pick 3, 4, or 2, 3, right? There's 3 good points that you can pick. It does not matter which ones you guys pick, all right? You can pick any one of those 3 points. I am going to go ahead and pick the point 4, 3. Okay, because I like to pick ones that are right next to my intercepts because it makes it a little bit cleaner. But you can pick whatever you want. So, guys, this is my X, and that's going to be my Y. So I'm going to say, all right, my Y is 3. But if you pick a different point, do that. And let's make sure we get the same A value. Parentheses 4 minus 1. Okay? Times 4 minus 5. Okay? So then that is equal to 3 equals A times 3 times negative 1. Do y'all feel good about that? So 4 minus 1 is 3. 4 minus 5 is negative 1. So that becomes 3 equals A times 3 times negative 1. That gives me negative 3A. Divide both sides by negative 3. And my A is equal to negative 1. Guys, looking at your graph, does that make sense for my A value to be negative? Yeah, because my graph faces down. So that makes sense that my A value would be negative. So if I'm going to write my equation, it's going to be y is equal to negative, and you don't really have to put, you can put negative 1, or you can just do a negative, parentheses x minus 1, parentheses x minus 5. Do y'all feel good about that? So that's how you can write your equation in vertex form. And once again, guys, you can always check yourself with your lovely guy here. All right, guys, so you can always check yourself. You can say negative x minus 1 times x minus 5. And then, oops, I was not, so negative x minus 1 times x minus 5. I'm going to graph that. Make sure it actually looks. Hey, my graphs match, so we're good. All right, y'all? So now I want you guys to do 6 and 8. I want y'all to do numbers 6 and numbers 8 based on that guy right here. This is writing a quadratic equation in our intercept form. Okay? I want you to choose to do these in intercept form right now. All right, y'all? All right, guys, so you can look up here and see if you are correct here on number 6. All right, y'all? So my roots were negative 2 and positive 1. So we plugged both negative 2 and positive 1 in. And guys, when you plug in that negative 2, it makes it x plus 2 and x minus 1. Okay? And then I picked the point 2, negative 10. Did anyone pick 0, 5? That would have been a really good one. I didn't think about 0, 5. All right? So here we go. So I picked 2, negative 10. So we got negative 10, A, and then 2 plus 2 and 2 minus 1. So that was negative 10 equals A times 4 times 1. So negative 10 equals 4A. And so that, and then we divided both sides by 4. So we got negative 5 halves. If you picked a different point, you still would have gotten the exact same A value of negative 5 halves. And for number 8, y'all, this one was a little tricky. Because, guys, your A value ended up just being 1, right? That can happen. So, guys, if you plug in a 1 for your A value, technically, we just get x plus 2 and x minus 4. Do y'all feel good about that? Excellent. Okay? So now what I'm going to do, y'all, is I'm going to show you guys a quick little regression on the calculator. Okay, guys? So for these last two, I'm going to go through it once with you, and we're going to do this again on some other ones later this week. But guys, if we want to write it in our standard form, guys, what is the standard form of our quadratics right here, y'all? Y equals what? Yes, y equals ax squared plus bx plus c. So guys, if you are given a table of values and you are asked to write it in standard form, you can do it two ways. You can do it on this one, you could do it in intercept form and then convert it to standard form, or you can do it with our calculator here. Yes, sir. You got a question, Dylan? You're just stretching. Okay, perfect. So, guys, let's go through our little. Let's go through this on how we do our quadratic regression in our calculator here. We've done it with linear and we've done it with our exponential, but we haven't done it with quadratics yet, right? So let's go ahead and remind ourselves how to do this, all right? So the first step, I actually have all the lovely steps for us on here, correct? So our first step is we want to go ahead and we want to input the value into the calculator. So the first step is we hit that lovely little stat button, correct? Then we want to edit our list because we want to enter our data. So we will do that, and we enter all of our x values into list 1 and all of our y values into list 2. So why don't you guys take a second and go in and do that? You probably have faster fingers than me. All right. Did I do that correct? Check yourself. -3, -2, 0, 1, 2. Excellent. All right. And then do your list 2. Make sure you get that in there correct. All right, y'all? Excellent. Once, I know it's so shiny on my calculator, I'm sorry. So once you have your data entered into your calculator, now we want to calculate. So you go to that lovely little stat button, and now we aren't editing our data, we are calculating something. So you go to calculate. This menu should look familiar because we've done it for linear and we've done it for exponential. But now we want to do it for what kind of functions are we looking at, guys? So we're going to jump down to quad reg. There we go. Whoops. Quad reg. You can click number 5 or you can scroll down. Do a little double check there. X list is list 1. Y list is list 2. Awesome. And you calculate it. And guys, it spits out your A, your B, and your C value. Okay? So if you are asked for it in standard form, not intercept, not vertex, we actually put it in. So guys, it gives us our A value, which in this case was equal to 4. It gives you your B value of 4 and your C value of -24. So guys, now we get to just write our equation, right? So if I ask for it in standard form, that one is very nice. I'm not going to lie, guys, it's not going to happen often. You're probably going to have to write it in vertex form or intercept form a little more often, but hopefully we can see that. So what I want you to do is I want you guys to practice that on number 10. I'm going to walk around, I want to answer, I want to make sure we can type this stuff into our calculator. All right, guys? It seems silly, but honestly, practice. You got to practice it, okay? See what I'm doing.
Just press enter and just like that.
Oh, yeah.
Oh, never mind.
What's 4 times -2? Does that help? Yeah. Good job. All right, how are we doing? All right. All right, so what do you not understand? Okay, cool. So where do we put it in? So we want to find what we're not putting it in Alright, how are we doing? You guys feel good about entering it? Yeah, that's really nice, right? So if I ask it in standard form and you have your tables, right? But if I ask for the other ones, just a quick reminder. And guys, because we've done it a couple other times, all you're doing is you're changing which one you click on the menus, right? Yeah, because you've already entered it, and we want the quadratic regression this time. Perfect. All right, y'all. So that's just a quick little refresher on how we do that. All right, guys, so I want y'all to turn the page. We got one more little thing we're going to do here. All right? So let's turn. Okay. So, guys, now we're going to do a couple examples where we change our forms, okay? So we start with something, and then, guys, most commonly, I will ask you to change it to standard form. Yes, sir?
still have the last one?
Yes.
Where we made it from standard form. Couldn't we just do that with the graph one and change it like intercept form or whatever?
Aha! So yes, you're absolutely right. So because we just did it on number 10 here, what Cole was asking is he said, could we just do intercept form on this one? Well, we probably wouldn't do intercept form. We would do vertex form because there's a vertex. We would do intercept form on number 9, right? So we could put it in vertex form and then convert it to standard form. Absolutely. But if I'm asking you for standard form, you could also just do the so you could do either one.
Well, I'm saying, couldn't you do like the other way where you're asking for intercept form or vertex form? Find standard form and put it into.
Yes, you could. And so we will that's actually, we're going to do that next unit a little bit more where we go backwards. And that's where we do factoring and all that good stuff. But yes, so now we're going to look at where we start here. We are going to start with vertex form, and we are going to put it into standard form. All right, guys? So we have parentheses. We don't want parentheses. So what we've got to do is we have got to go ahead and we have got to convert this guy. All right? So what we would do here is how could we rewrite this when we multiply it, y'all? X plus 3 squared. What do we want to do? Do we want to leave it like that? Yes, excellent job, Victoria. So we're going to rewrite that as negative 2 times x plus 3 times x plus 3, but we still have our minus 5, right? So, guys, this is going back like 2 units, all right? Now we just get to multiply our lovely polynomials here, our binomials. And so the first thing I would do, guys, is I would take care of these guys here, all right? So how are we going to multiply our x plus 3 times x plus 3, y'all? What is that going to give us? We still have our negative 2 in the front. So we do x times x. What does that give us? X squared. X times 3. 3x. 3 times x gives us 3x. And 3 times 3 gives us that 9. Right? So I went ahead, we multiply that guy out. Is this totally simplified, y'all? No, we want to go ahead and simplify that. So I'm going to leave my negative 2 out here. Let's simplify that. So we have our x squared. We are going to combine our like terms. 6x plus 9. Okay? So this takes a few steps along the way. So now that we have simplified those 2 binomials, we've multiplied those guys together. Now we want to take care of distributing our negative 2, correct? So we go here. And so what is the first, how are we going to simplify this first set here? Zach, can you help me out? Negative 2 times x squared, what we got?
Negative 2x.
All right, can you do the rest of it for me?
Yeah, negative 2x squared. Negative 12 squared. Negative 12x.
There we go, negative 12x.
And then negative 6.
And, ooh, negative 2 times 9 would give us, what is that going to be?
18.
Negative 18, yes, sir. But then we still have our lovely little minus 5. We haven't done anything with that yet. So we are almost done, but not quite. So Mariana, how are we going to finish this off here? Yeah, we're going to do our negative 18 minus 5. So what's our final answer going to be? Negative 2x squared minus 12x minus 23. Excellent job. All right, y'all? So what I want you guys to do is I want you to do the same thing on number 2 over here, and I'm going to walk around and check that out. All right, guys? I want y'all to do that on number 2. We're going to check it out. We're going to see how we're doing, all right? So we are converting it from vertex form to standard form. Why would we do that? What does vertex form tell us?
Vertex.
It tells us the vertex. What does standard form? What does standard form tell us? The y-intercept, okay? So they're valuable for different reasons. So sometimes it's better to have it in vertex form. Sometimes it's better to have it in standard form. Excellent. Just doing the math, right? And the same can be said for our lovely little guys here. Excellent job. How you doing, Cindy? And how can you check yourself? I see some of y'all doing that. What could you do to check yourself? Any ideas?
Put them both in the white.
Put them both in y equals and check the equivalency there on the table or on the white. Yeah, those are great ways to check your equivalency. I highly recommend doing that. If you're done, check your equivalency in your y equals before I flash it up there. All right, and then you don't even have to ask me if you're right. You just get to know you're right. All right. All right, so when we look at number 2, hopefully that should feel pretty good. All right, we had 5. I saw a lot of us getting this here. We had 5x squared minus 20x plus 24. Guys, there's just a few steps we got to take. So the biggest mistakes that I see students that I see y'all make is, and myself sometimes as well, guys, is kind of forgetting about this one here at the end. You do all the work, you even distribute this one, and then you just stop, right? And when we stop there, that would not be correct, all right? We would be off. Our y-intercept would be off by 4 there. So guys, you got to make sure you don't forget the little extra k there, right? That little extra spot on our vertex, okay? So now what we're going to do is we're going to take a look at what this looks like if we start with our intercept form, right? Intercept form is wonderful because it gives us our intercept. But if we want to know something else, if we want to convert it to standard form, then we got to do something. Now, guys, I actually like intercept form a little bit easier because we don't have to rewrite it, don't we? Okay, so how would we do this? Knowing that we just did standard form, what do you think we should do to simplify our intercept form? Danielle? Yeah, we're going to multiply our 2 binomials together. We're going to multiply those parentheses. So I'm going to go and do it in a different color. So we got x times x, and what does that give us? X squared. Excellent. So we're going to multiply those lovely parentheses out. X times 5, we get our 5x. And then y'all know the drill. We get our negative 3x and our negative 15. Okay, are we done? No, we got to put these guys together. We got to simplify it. So our next step, we still have our lovely 2 on the outside, but we got to combine our like terms. So what's 5x minus 3x, y'all? 2x. So we got x squared plus 2x minus 15. Forgot my different color here. That'll be okay. Okay, are we done? What's our last step that we got to do there, Isaiah?
Multiply 2 times x squared.
Yeah, but everybody else, right? We're going to distribute it in. Excellent job. So 2 times our x squared. So what is that going to be for us, Isaiah? Can you finish it off?
2x squared.
Excellent.
And 4x.
Yes, sir.
Negative 30.
Yes, sir. All right. So personally, I like converting from vertex form a little bit easier because you don't have to remember to add anything at the end, right? You don't have to rewrite it. You don't have to add anything in, and that would be that. So I want y'all to do number 4, and then, guys, we are going to get ready for a short little activity that will help us review our attributes. All right, guys? So we are done with that here today. All right, guys? So I want y'all to do number 4, and then we're going to get started on our activity.